So now we're leaving Balmer. Balmer, where are we headed?
Balmer, we are headed down to Reading.
No, it's not Reading.
We're going to begin with demolition and excavation and get this job rolling.
All right, fired up. You're sitting in the audience, you're thinking, oh my God, they're going to talk about permeable pavements again. Are you kidding me? We can't sell permeable pavements in our market. Why are they talking about it again? Well, let me give you some advice. Stop trying to sell permeable pavements. Just stop. Get to the explicit need. Talk to your consumers about their problems. I sat with this lady in Reading, Pennsylvania, and I said, how can I help you? She said, I walk off of my front porch. I step onto the walkway either into water or ice. Can you solve that for me, Paver Pete? Yes, ma'am. She points to this tree in her front yard, and she says, this tree has no value to anyone other than us, because we planted it, our kids, us, we planted it together. I would like to save the tree. Can you save the tree, Paver Pete? Yes, ma'am. She goes, it's summertime. I would love for you guys to be out of my front yard really quickly. Can you do that for me? I said, yes, ma'am. And I did it with permeable pavement. I was in and out with the walkway installation in one day. All the plannings took us a second day, 2 days, in and out. We solved all her drainage problems, and we preserved her tree, and we did it with permeable pavement. I didn't sit down and discuss angular stone with 90% fractured face, less than 5% passing the two. Because she doesn't care. She doesn't. Can you solve my drainage problem? Yes. Can you save my tree? Yes. Can you be in and out in a day or two? Yes. That's permeable pavement, folks. Every job like this one starts with a forensic analysis. We got to know what we're dealing with so we can solve the problems. Once again, Techo-Bloc and a local Techo Pro contractor are saving this homeowner from another boring landscape. We're going to pull all this landscaping out and give them a more rustic feel, our new valet paver. We're also going to give them some environmental benefit. We're going to install it in a permeable application. The contractor loves that. It's busy season, and this walkway, step, and stoop can be done in 1 day's time. An additional day will get all the landscaping done. The layout, we're going to work with our existing grades and pitch that water down, most of it going through the subgrade. You can see some failures around this site. We're going to deal with those. We have the root zone system over here. We have some edge failure and a couple of fairly significant sinkholes. This was done on all stone dust or screenings or quarry waste, which has eroded away. We're going to solve that problem for them as well. So we're going to start with excavation and demolition and get this job started.
How many of you guys have seen things like this on your projects?
Put your hands up. How many of you have seen a job like this? All of you, put your hands up.
How many of you guys take these pictures of these failures and show them to your homeowners, your prospective clients, and say, buyer beware?
Think about that one. How many of you in this room have a section of your website that says, buyer beware? This kind of work is being done in Connecticut. Can I get an amen? Can I get an amen? And how do we stop it? How do we stop it? We sit at a kitchen table and we try to talk to those homeowners and explain that we'll be different, we'll be better, you pay me more and you'll get more. And they go, you're lying to me, because they don't know you. Start showing them pictures like this. Don't tell them who did the work. They don't need to know. You don't need to get into that game. But show them these things and say, this is being done. We don't build it this way. This is why it occurred. Here's how we're going to solve it. Now, we have cross-sections that can help you. We have cross-sections. Everybody has a handout.
So this is your typical permeable pavement system crosscut. And obviously in this system, we got to put our 2 and 3 inch ballast stone, because this lady has her pet elephant or her railroad track she wants to build down her front walkway, right?
Yeah, ridiculous. So
what we're saying is, let's make that 2 and 3 inch ballast stone optional.
Am I up on the screen? Yes, I am. Excellent. Yep. So for the first time ever, the industry doesn't say it, none of our competitors say it, no one is saying it, but the 2 to 3 inch ballast stone is an option. We're building a residential walkway in Reading, Pennsylvania. We don't need ballast stone. But what if we did need additional strength? What if we did have to handle repetitive elephant traffic load? That would be crazy, but let's just say, what could we do to make this pavement stronger, Chris?
We're saying let's integrate some biaxial geogrid into that base to add structural integrity to that system.
So sandwiching a layer of biaxial geogrid in our base, we can make this strong enough to handle repetitive vehicular truck, whatever we wanted to do here. Okay, I like that. Show me another drawing. Uh-oh. Look at the height of the exfiltration pipe in this drawing, folks. You don't see drawings like this. This is loaded up on our knowledge-based website. You can get it from me, Chris, any of the men in black. Why is that pipe so high in the horizon? You never see it this way. Well, let's imagine we're getting a 50-year storm. What's a 50-year storm here in Connecticut? Who knows? 50-year storm. 2, 3 inches an hour? No, not much more than that. 50-year storm, what is it? Tell me, I don't know. Huh? Let's say 4 inches an hour. That would be a lot. I think that's too much. But let's say you get a 4-inch rain event. 50-year storm. What's going to happen, Chris? We got rain in the environment, right? Rain's coming down. It saturates the joints. It eventually fills into our base, right? That's rain. Is that rain?
Those are raindrops.
I will take the pen from you. You realize that,
rain.
right? Okay. And then that water will fill into our subbase or base, and it will infiltrate naturally into the soil. It'll recharge our water table. It'll be absorbed into root matter and evapotranspirate back into the environment. But let's say we get a 100-year storm. Muscle man, how many is that? 8 inches an hour. Let's say a 150-year storm, 12 inches an hour. Now what do? System can't handle it, can it? So now we're going to let that water back up into our exfiltration pipe. We can build an adjacent subterranean drainage structure like a dry well, and that dry well, full of clean stone, can now absorb and let that water evaporate or evapotranspirate back out into the environment. Show me another drawing, please. Nice thing about that is that dry well isn't dug to China, too. Who's ever seen a permeable pavement like this? A pitched subgrade with an exfiltration pipe in the lowest grade point. Holes down, 4 inches of clean stone completely around the pipe, right? Holes down. All this is loaded up on our knowledge-based website. So now we get a rain event, all 3/4 inch angular stone, no subbase in this drawing at all, 1 layer of biaxial grid. We can do a lot of things with an application like this. Show me another one. Uh-oh. When would you build this? When would you build something like this? What would be over here on the right side of the screen that would make you build this way? A house is the correct answer, except if there were a house. Are you drawing a house now?
Yes, sir.
Oh, goodness. I'm taking the pen. What would we have to do against that foundation wall? Because a lot of manufacturers are talking about open graded stone in every application, which is wrong. What would we have to do, Chris, against that foundation wall?
We could lay an EPDM liner up against that foundation to make sure no moisture is getting into that foundation.
So we would have an EPDM liner extending up the foundation and 6 to 10 feet out. So there's an expense and time and labor that goes into building a permeable pavement against the foundation wall that a lot of people aren't talking about. So if you had one, you need that EPDM liner. Show me one more.
So we are the only manufacturer in the industry that are still recommending a solid laid header or border course around our permeable pavement systems.
So laying a true interlocking system around the perimeter and an elevated curb system, right, is a part of the erosion and sediment controls so that wind-blown debris, leaves and Dunkin' Donuts lids and cigarette, whatever, but is that debris?
Those are leaves and debris.
Okay.
Yep, that's it.
All right. I'm guessing that's debris. Okay. Now we can sweep that into a pile, shovel it away, no problem. We haven't contaminated the joints of our system. So we can reduce the amount of maintenance a permeable pavement sees by designing it properly from the beginning. Show me the next drawing, please. What's this one?
So this is a downward sloping driveway into a garage. So we need to build some elevated dikes in that subbase to stop that flow of water downward into the house.
So elevated dikes, excavating to the angle of repose of the soil. We've got little landings the water can infiltrate naturally. Anything that does overflow, we'll catch it in an exfiltration pipe and we'll run it off. Folks, all of these are loaded up on our website. Go there, download them. Drop your logo in the upper right-hand corner. Laminate them. Laminate them. Get some colored markers. Keep them in your backpack. Keep them in your briefcase when you're sitting at a kitchen table. Don't bring them all out. Bring the appropriate ones out. Explain to the consumers what they're buying, and believe me, they'll pay for it. They understand what they're paying for, and they will come up with the money. These are great drawings. Put me back up on the screen, please. Okay, scarification of subgrade. All right, fired up. Our excavation's done on our permeable pavement walkway. We've dug down that 9 3/8 inches. We have scarified that subgrade. We've used a tooth bar on the front end of our loader to scarify that surface. Our intention was to go down that full 4 inches. But due to the high clay content of our soil subgrade, we weren't able to do that. The soil's just too cohesive. So we've gone down 2 inches. Why are we doing that? That opens up the surface to allow for a greater rate of infiltration. Come on, guys. Now we're bringing in our number 8 stone. This is our filtration medium. It's going to catch any of the fines that may travel through our system and catch them before they clog that subgrade. Will also help our bearing ability and our rate of infiltration. Once that's done, we'll finish up our geotextile fabric. You can see it's shingled with the flow of water. It's tensioned with piles of stone. Never put holes in it. That's an Alliance geotextile fabric. It has an apparent opening size of 70 to 100 and a weight of 4 ounces. That's what you want to use in a permeable pavement under pedestrian traffic. Let's keep going. We get out to the job sites in the springtime and we're building an interlocking pavement, and it's just wet and the clay's so mucky we can barely walk around. It's just sticking to our feet. We know what to do. We can add clean stone to it. We can add number 57 3/4 inch angular stone, change the gradation, help dry out the clay. It's called a gradation amendment. There are chemical amendments to clay subgrades as well in an interlocking pavement application. Give us one.
I think the best is lime.
Lime.org. Go to lime.org. If you've never been there to look at how you have a change in the positive-negative attraction of clay particles to water molecules and how it dries them out. There's others.
Like type S mortar mix, maybe?
Yep, Portland cement, lime kind of mixed together. But what do we do in a permeable pavement application? We can't do those things. Here's what we can do. We can scarify that surface. Open up its surface area. I'd love to get that 4-inch tooth all the way through. It's just too cohesive. So we scarify. We incorporate a washed concrete sand or a 3/8 inch chip we call number 8 stone. And that is going to aid in infiltration, filtration, and improve the bearing ability. Now, geotextiles. There's a lot of misinformation about geotextiles and permeable pavements as well. Everybody welcome Kyle Moyer to the stage, please. Kyle. Now, a lot of us feel that we can only use the non-woven geotextiles in a permeable pavement. They look like felt material. And if you hold them out and you pour water into those felt materials, you can see that the water dissipates very, very quickly. But in a vehicular traffic application, there are times when it would be better to use a woven geotextile fabric like this one. It has what's called bilateral tensionability. It can bridge minor differential settlement of the subgrade just due to the nature of it being woven. But a lot of us get scared. Wait a minute, this is a polyester hydrophobic material. Polyester like Chris's pants. Is it too soon? It's also petroleum soaked. So you've got petroleum, you've got polyesters, both hydrophobic. This obviously will not work in a permeable pavement application. So, thank you. We can prove it by simply putting some water into that fabric. And you're going to see very little water will pass through that fabric. So obviously, we can't use it in a permeable pavement application. That's making a visual observation and saying yes or no on a fabric. That's not how you do it, folks. You got to look at the apparent opening size of that fabric and find out, will it work in an application where it is subject to the load of aggregates and subject to the load of pedestrian or vehicular traffic. And under that load, you can see that that water, once it comes in contact with that stone, that fabric opens up and the water dissipates very quickly. It may look like silt fence, but it is not silt fence. It has the appropriate AOS or EOS and can be used in permeable pavement applications. Kyle, thank you very much. Give him a round of applause, everybody. We spec geotextile fabrics based on data, not on visual observation. Put me back up on the screen, please. Okay, let's look at geogrids and how they work in pavement. You're sitting at a kitchen table, and you're talking to the husband and wife about building them a backyard patio, a driveway, or whatever it might be, and you start talking about biaxial geogrids, and the benefits of biaxial geogrids and how they can make that pavement stronger and get them a better life cycle. And those homeowners are looking across the table at you going, what are you talking about? I've had 3 other contractors come in here to bid this project, and not one of them has even said the word biaxial geogrid. I think you're trying to cheat us and get more money out of it. That's what they're thinking. That's why we created animations like this, folks. This is loaded up on our YouTube channel. Download it. Put it on your iPhone, your Android, your iPad, your computer. And when you're sitting there talking to them about incorporating biaxial geogrids and pavement, show it to them so they understand the conical distributional load. And what you're telling them is very important.
Compaction, compaction, compaction. That's been our mantra in the hardscape industry. But when using open graded stone or permeable base, commonly called ASTM number 57s, 3/4 inch clean, angular, symmetrical material, little to no compactive effort is needed. In this application, in this environment with a deep frost line and lots of freeze thaw cycles, our typical base would have been 9 inches. We don't want to do that. We're going to be able to save money for the consumers and get in and out of this job quicker with a 6-inch base. To make sure it's plenty strong, we've incorporated a biaxial geogrid, an Alliance Gator grid, what's called 30/30. These biaxial grids are installed, no overlap, only abutting, with 100% coverage. Biaxial geogrids have changed the way we hardscape.
For those of you who are old timers, you probably have seen this little test. Those of you who are newer to the business, this is something new. What we're going to do is we're going to show the bearing ability of aggregates with and without the use of biaxial geogrids. So we're going to take this box, which is hinged on 2 sides, and we're going to fill it with stone, and we're going to put weight on it, and then we're going to see how it handles that weight, encapsulated and not encapsulated. We're going to use a 3/4 inch angular stone. We call it number 57 stone. This stone, in my opinion, requires no compactive effort. If you do compact it, just do it very little. You can tend to break the angular nature of the stone, change its gradation, and reduce its bearing ability by over compacting it. I'm going to put 2 5-gallon buckets of stone, no compactive effort at all. I'm just kind of flattening that area out. And I'm going to put this little platform in here so we can subject it to load. We're going to use this pipe because I had my hip replaced about 9 months ago. So I don't want to risk anything. Thank you very much. So now I'm putting my weight on it. I weigh 145 pounds. All of a sudden, I'm funny. Do you see that? I weigh slightly more than 145 pounds. And you can see that this stone very easily bears my weight. There's no movement. There's no nothing. It is encapsulated, in this case by a box, but it would be trench walls. So you can see that I am very stable in this application. Now, these guys are going to unhinge the box. They're going to pull one side of it off, and they're going to do it slowly because as they move the encapsulation off, and you can even slide that. You put that on the ground, Kyle. You can see that the more they move it, that aggregate finds its own natural angle of repose, an angle at which it is stable on its own without those trench walls. Okay, let me get down off of here. Now, we are going to do the same test again with the inclusion of biaxial geogrid. We're going to use the same stone again. We do have plenty of stone up here, but I don't want anyone to think that we're doing a fast one. This is just clean stone. So we're going to use the same stone, second time. All right. Chris will get that. All right. Let's go on this side. We're using the same stone. Nobody will think we're pulling a fast one. Same material. We are using a geotextile fabric. Can you get the shovel back up? We are using a geotextile underneath. The reason we're doing that is you'd have a geotextile anyway. And we're going to rehinge the box and do the test all over again. This time we're going to do it with 33% more stone. We're going to put a third bucket of stone in here. Okay? Cool. So now, starting to put some stone in. Again, no compactive effort. I have a layer of biaxial geogrid. It does extend up the sides of the excavation just a little bit. That's okay. One thing we don't want to do is have geogrid overlap geogrid. Geogrid never overlaps geogrid. Geogrid has what's called apertures or openings. Anytime that it overlaps, you reduce the size of that opening or aperture and reduce its strength and increase its friction plane, which is not how it works. We want to have that friction. This is a biaxial geogrid, which means it has strength in two directions. In a retaining wall, we use uniaxial geogrid, which has strength perpendicular to the wall face. Why don't we use biaxial grids in retaining walls? Well, it costs more and we don't need the strength. Unless we're building steps, or maybe have a return wall. All right, we got two more layers. We got one more bucket. Now we're again using a third bucket of stone, more material. Three inches is a really good number for the amount of stone between layers of geogrid. 3 inches of stone. Anything less than that, you're really not getting the same benefit. So now we're at 33% stone, no compactive effort. Put my little plate back on there. Once again, 145 plus pounds. And you can see there's no, but it's encapsulated. So you can see that there's the same strength, the same integrity in a trench with this stone, with or without the geogrid. Now we're going to unhinge the box. Go ahead, guys. We're going to unhinge the box. They're going to pull it out slowly. You will see some erosion of that stone around the perimeter. Obviously, it's just loose stone. And even as he slides that back out, you can see that the column of stone and its integrity is not compromised because of the inclusion of a biaxial geogrid. Make sense? Cool. Cool. All right, help me down. Thank you, sir. You know I'm important here. Don't let me fall. All right, yeah. All right, Kyle Moyer, everybody. Put it right back where it was. Okay, put me back up on the screen, guys. Cool. Uh-oh, Techo quiz. Techo quiz.
If upper body weight is 105 pounds, bending
John,
over to
walk
pick
up and down the aisles, please. Thank you.
to pick up a stack of pavers that weigh 10 pounds applies how much pressure on your lower back?
All right. The answer is C. 1,150 pounds is the right answer. We learn by doing. After carrying pavers for many years by hand, scratching up the inside of my arms, ruining my shirts, figure out there's a better way. Carrying 10 pavers at a time to the laying face. Very quick, very efficient. Spin it out, grab more pavers. Our bedding layer's in. It's a 1-inch number 8 stone bedding layer. It's screeded, doesn't need any compaction. We can lay right on that surface. We're approaching completion on our permeable pavement install. As you can see, we've used our Victorian red black in an interlocking application as our border or header course around the project. The reason for that is sometimes you'll get wind-blown debris from the leaves shedding trees, the environment, and they will build up against that edge, easy to shovel and remove without contaminating the joints on our permeable pavement system. We're also using our Avignon as an elevated edge. It is also a component of our erosion and sediment control measures. It's set on the base with a slight mortar bed and then backfilled with steel reinforced concrete for integrity. That elevated edge will keep all the mulch and debris out in the environment where we want it. Now we're using a Durawall type product. Here you go, Rob. And we use it as opposed to rebar. It's very easy to bend. We're going to put plenty of overlap on it. And that steel is going to give us the strength that we're going to need in a deep frost line or a lot of freeze-thaw susceptible soil conditions environment. I'll bend this over here. Once that unit is bent, we'll be ready to backfill with concrete and we'll be good. Our joint fill here, you see sweeping into the joints, is Alliance Aqua Rock. It's a number 9 base stone. It's hardness tested. The material is symmetrical, no flat elongated particles, and less than 5% passing the 200 sieve. We want to sweep it in to just below the chamfer. We're going to check to make sure that it's completely consolidated in full using a putty knife test. If I can get more than 1/2 inch penetration with that putty knife, then I know I need to re-sweep and reconsolidate. But we're good here. We affectionately call this the Techo-Bloc Permeable Pavement Cheat Sheet. It is loaded up on our knowledge-based website. Upper left-hand corner, you see our logo. Below that, Blue 60 and 80, our #1 best-selling product, is a dual-purpose product. Can be installed permeable or interlocking. Below that, something new.
Blue 6x13, we've done the testing. It is now rated for permeability.
So 60 and 80, herringbone pattern, running bond pattern, stack bonds, Blue 6.5x13, Antica, Victorian Permeable Villaggio Mista Pure Inflow Valet, you know about them, 3 new ones.
Mica, Travertino Raw, and Aquastorm.
And Aquastorm, another big change, percentage void space installed. We have traditionally given you percentage void space manufactured as it comes out of the mold cavity. That's just not realistic. So this is better real-world data. That's what we're giving you. Joint openings, rate of infiltration. The bottom 3 are brand new. I don't have those yet. We'll get them soon. Joint fill. Then you see that little blue logo. That's the ASTM, the American Society of Testing and Materials. It's the U.S. standard for permeable and interlocking pavement. Do we pass that? Yeah, quite easily. The next one is CSA. That's the Canadian Standard Association. What's that mean?
It's the most strict testing you can do in the world on pavers.
So, freeze-thaw durability in salt water. Do we pass that? Yeah, pretty easily. USGBC, the U.S. Green Building Council, and LEED accreditation, leadership, energy, environmental design. Do you get points for using our permeable pavement systems? Absolutely. Over there in red, you see ADA. What's that?
That is Americans with Disabilities Act. That means it's firm, stable, and skid resistant.
So what does skid resistant mean?
I do this creepy test with a swinging arm with fake human skin touching the pavers.
Yeah, it's kind of creepy. It's called the Broom Grabber Mark III British Pendulum Test with simulated human skin. And yes, it is a little creepy. Folks, all the data you get from Techo-Bloc's real-world data. The rate of infiltration on valet, we got it on that little walkway in Reading, Pennsylvania. No indoors under controlled condition testing from us. So remember,
Scarification of the subgrade increases infiltration. Do that back drag with your bucket. Open up that infiltration rate of that soil.
geotextile and permeable pavement. We no longer pick them with visual observation. We need to know grab tensile strength, 110-pound minimum, weight 4 ounces, and an AOS or EOS, apparent opening size, equivalent opening size of 70 to 100. That's the thread counts per inch. That's how we make the decision.
Incorporating biaxial grid stabilizes and reduces base thickness. You guys saw the demo up on the stage. Incorporate some of that biaxial grids into your base to increase structural integrity.
We've been doing this kind of thing in pavement for thousands of years, and we stopped. I don't know why. We're bringing it back. Start using grids, start using fabrics. When appropriate, let's reduce our base thicknesses.